Ever tried to, like, slice a tomato with a ruler?
No.
Yeah, doesn't work too well, does it?
Right.
You need the right tool for the job. And in the world of materials, titanium, that's like the super sharp chef's knife everyone wants in their kitchen. Welcome to our deep dive on titanium. You've sent over a whole bunch of articles and research on this metal. Honestly, when I saw this stack, I thought, this is going to be dense. But even I was surprised by how fascinating this stuff is. We're talking strength, lightness, even a dash of, like, invisibility. Well, almost. More on that later.
Yeah.
So first things first, what makes titanium so special?
Well, what's incredible is that it punches way above its weight class. Imagine the strength of steel, but like packed into something almost half the weight. That's titanium. Engineers love it. It's like getting the best of both worlds.
Okay, so I'm picturing a lightweight boxing champ here. But how strong are we really talking? Give me a comparison even I can understand.
Okay, let's put it this way. Imagine a few elephants balancing on something as thin as your fingernail. That's the kind of strength some titanium alloys can handle. It's about 60% denser than aluminum, but it can be more than twice as strong. We're talking alloys like beta C, which just blows common aluminum alloys like 61T6 out of the water in terms of tensile strength.
Wow, twice as strong. No wonder they use this stuff to build spacecraft.
Right.
But hold on, you keep mentioning alloys. Is titanium like a superhero that needs a sidekick to reach its full potential?
You got it. Alloying is like giving titanium a custom upgrade. By adding small amounts of other metals, things like aluminum, vanadium, or molybdenum, we can fine-tune its properties, knead it even stronger, more resistant to heat. There's an alloy for that.
Titanium.
Yeah.
The customizable superhero of the metal world. And let's not forget its other superpower, laughing in the face of corrosion. Yeah. This stuff stands up to seawater, acids. Well, the secret sauce.
Okay, picture a microscopic force field. When exposed to air, titanium forms a thin, invisible oxide layer. That acts like a shield against corrosion. And this layer is non-porous, meaning it doesn't have any holes or weaknesses for corrosive substances to attack. It starts small, just a few nanometers thick, but over time it grows into this formidable barrier, protecting the titanium underneath.
So we've got this super strong, lightweight, corrosion-resistant metal just hanging out in the periodic table. But how did we even discover it in the first place? Was it a eureka moment or more of a slow detective story?
It's actually a bit of both. Our story begins back in 1791 with William Greger, a clergyman and amateur geologist, talk about a side hustle. He was intrigued by this black sand he found in Cornwall, England. What made it unusual was that it was attracted to a magnet.
Wait a minute, magnetic sand. Now that's just strange. Sand isn't usually magnetic, is it?
Exactly. That's what caught Greger's attention. When he analyzed the sand, he found iron oxide, which explained the magnetism. But he also discovered a white oxide he couldn't identify. He knew he was onto something new.
So titanium was hiding in plain sight, disguised as sand. Okay, what happened next? How do you go from mysterious sand to, like, a revolutionary metal?
Well, that's where the detective work really began. Isolating pure titanium proved to be quite a challenge. You see, titanium is highly reactive, especially at high temperatures. The usual methods for extracting metals, like heating the ore with carbon, just wouldn't work with titanium. Instead of getting pure titanium, you'd end up with titanium carbide.
So no shortcuts, huh?
Right.
Sounds like they needed a whole new playbook to extract this stuff. So how did they finally crack the code?
It took decades of research and experimentation. Finally, in 1910, Matthew A. Hunter managed to isolate pure titanium by heating titanium tetrachloride with sodium under high pressure. It was a huge breakthrough, but this method wasn't exactly practical for large-scale production.
It's like finding the secret ingredient, but not having the right recipe to make it work on a larger scale. So what was the turning point? When did titanium go from a laboratory curiosity to a metal we could actually use?
That's where William Justin Kroll enters the picture. In 1932, he developed what we now call the Kroll process. It still involved some tricky chemistry, using magnesium to reduce titanium tetrachloride, but it proved to be more cost-effective and, crucially, scalable. This paved the way for the large-scale production of titanium we see today.
From a mysterious black sand to a breakthrough process. It sounds like titanium took the long way around to arrive on the world stage. Welcome back to our titanium deep dive. We've established that titanium is strong, light, and laughs in the face of corrosion. But where does this wonder metal actually show up in our lives? I'm guessing most of us aren't bumping into, raw titanium every day.
You'd be surprised. The most common use of titanium isn't in some high-tech gadget or spaceship. It's actually in something you probably used this morning.
Okay, now you have to elaborate. Don't leave me hanging.
All right. Picture this. You're getting ready for your day. reaching for toothpaste. That bright white paste, yeah, that likely contains titanium dioxide.
Wait, hold up. Titanium is in my toothpaste. And here I thought it was all like rocket science and fancy airplanes.
It's easy to miss, but titanium dioxide, or TiO2, is a workhorse of a compound. About 95% of all titanium ore ends up as TiO2. It adds that brilliant white to not just toothpaste, but paint, paper, even some plastics.
So when I see a crisp white wall, I'm actually looking at titanium. Mind blown. What makes titanium dioxide so special for this? I mean, there are other white pigments, right?
Oh, titanium dioxide is in a league of its own. It's incredibly bright, opaque, and it reflects infrared radiation like a champ. Remember those old observatories using white paint to stay cool? That was likely titanium dioxide at work. Plus, unlike some older white pigments, it's non-toxic and resists fading. Your white t-shirt stays white longer thanks to titanium.
Okay, I'm starting to think titanium dioxide is the unsung hero of the color white. It's not just about aesthetics, it's about safety and durability too. But I can't let you off the hook just yet. What about titanium's reputation as, like, a high-tech superstar? That's got to be about more than just making our toothpaste pretty.
You're right. Titanium doesn't shy away from the spotlight when it comes to high-performance applications. When engineers need a material that's both incredibly strong and light enough to take to the skies, titanium is the answer. We're talking aerospace engineering at its finest.
Speaking of aerospace, I can't talk about titanium without picturing the SR-71 Blackbird, one of the fastest aircraft ever built. It was one of the first to use significant amounts of titanium, just pushing the boundaries of speed and altitude.
The Blackbird is an iconic example, but titanium's reach extends far beyond that. These days, you'll find it in jet engines, missiles, even spacecraft like the Boeing 787 and Airbus A380. We're talking rotors, compressor blades, landing gear, even firewalls, parts that need to withstand incredible stress and heat.
So titanium helps us fly higher, faster, and safer. But it doesn't stop there, does it? I've heard whispers about medical marvels involving titanium.
You heard right. Titanium's biocompatibility, its ability to exist peacefully with the human body, makes it a game changer in the medical field.
This is where it gets really personal, right? We're talking about implants, hip replacements, bone plates, dental implants. It's literally giving people a new lease on life.
It's remarkable, and it's not just about being non-toxic. Titanium has this uncanny ability to osseointegrate, meaning it can actually fuse with bone. Imagine a material so compatible with your body that it becomes part of you.
That's mind-blowing. So it's not just replacing bone, it's becoming part of it. Incredible.
And there's another fascinating aspect. Titanium's lower modulus of elasticity, basically how much a material resists deformation, actually makes it a better match for bone than some stiffer metals. This helps distribute stress more naturally, reducing the risk of complications down the road.
Okay, that's fascinating. So titanium is not only strong and light, but also flexible enough to work with our bodies, not against them. That's some next-level bioengineering. We've covered a lot of ground here, from titanium's humble origins in black sand to its role in cutting-edge technology and life-changing medical applications. But before we wrap up this deep dive, there's one more aspect of titanium we need to explore. So we've seen titanium go from sand to spaceship, from paint to implants. But every superhero has its kryptonite, right?
Yeah.
There's got to be a flip side to all this titanium awesomeness.
You're right. It's not all smooth sailing in the world of titanium. It does come with its own set of challenges.
All right, hit me with it. What's the catch? What makes titanium so tricky?
Well, one major hurdle is the cost. Remember the Kroll process we talked about? As ingenious as it is, it's pretty energy intensive. And that combined with, the complex process of extracting titanium from ore, well, it makes it a more expensive metal, especially compared to your everyday steel or aluminum.
So titanium's kryptonite is its price tag.
Yeah.
That makes sense, especially with all those intricate steps involved. Are there any other, drawbacks?
Another challenge stems from titanium's reactive nature at high temperatures. Remember how tough it was to isolate pure titanium in the first place? That same reactivity makes it trickier to work with, especially when it comes to welding or machining. You need specialized equipment and techniques to prevent contamination and ensure those super strong bonds.
It's like titanium wants to keep its secrets close, even during manufacturing. But even with these challenges, it feels like we're just scratching the surface of what titanium can do. What about the future? What are the, big dreams for titanium in the years to come?
The future of titanium is brimming with possibilities. One area that's really exciting is renewable energy. Imagine harnessing the immense power of the ocean with tidal power generators. Titanium, with its incredible strength-to-weight ratio and resistance to seawater corrosion, is ideal for building these massive, durable structures.
Titanium, powering a greener future. Now that's a vision I can get behind. What else is on the horizon?
We're also seeing titanium making waves in nanotechnology, where size really does matter. Researchers are exploring the use of titanium dioxide nanoparticles for some really innovative applications like self-sterilizing surfaces, advanced water purification, and even like targeted cancer treatments.
Wow, from massive ocean structures to microscopic particles fighting disease, titanium really does cover the spectrum. It's amazing to think how far we've come from that simple black sand.
It really is.
As we wrap up our titanium deep dive, I'm left with a sense of awe. We've unearthed its hidden depths, its remarkable properties, and its potential to, shape our world in incredible ways.
It's a testament to human ingenuity and our endless fascination with the materials that make up our universe. Who knew something as seemingly simple as a metal could hold so much wonder?
Exactly. It just goes to show there's always more to discover, always another layer to peel back. And on that note, we'll leave you with a final thought. What will you do with this newfound knowledge of titanium? Perhaps you'll look at that white paint a little differently, or marvel at the engineering behind a soaring airplane, whatever it is. Keep asking questions, keep exploring, and who knows what other hidden wonders you might unearth. Thanks for joining us on this deep dive.